All right. So this chapter, we're gonna learn about the basic requires the concept and definitions or really basic material devices, the PN junctions and semiconductors. So we might be learn about really basic the chemical, such as materials, conduction band, valence band, and atom as well, valence cell. So that is chapter one for the future. Chapter two and five for the future in analog devices, the electrons. Okay, so I hopefully you don't need it to more in detail or memorize, but you have to understand about concept. It's very important. Okay, so they have a lot of model, but Adam, but the Bohr atomic model is the one of very famous to understand easier for my class. So usually atom, in the center of the atom nucleus, which contains the protons right there and neutrons. The protons, the positive charge, and neutron is no charge, just the neutral. Okay. So electrons in concentric orbits or the shells that were shells around nucleus. Okay. So that was called as the electronic orbits or shells, or, that is the path of the moving the electrons. And then, so we needed to classify the atomic structure of really usually the stable atom that has the equal number of electrons and protons. Okay? Electrons and protons. So the one more time, I wanted to, the repeat again. I know you have already really each concept has learned before in high school, but nucleus is equal to the protons plus the neutron in the center of the orbiter of the atom. And electrons is a line in the orbit, the shells, the path of electrons that was the negatively charged, okay, electrons. Well, that's the minus in here. And neutron is like no charge in the center of the nucleus, okay? That was nucleus. It's very important. Right. So we're gonna more further to understand the deeply about atomic, from one of the sample exam, the Cooper. The Cooper is number of, from the chemical table, the 29. So the first number we're gonna know about is like the valence shell. Valence shell. What is valence shell? The valence shell is the any atom of the outermost shell, the given atom. We're gonna call that the valence shell. Valence shell of the atom is very important because it was determine conductivity of the atoms, such as the positive and negative. Okay, positive and negative. So from these slides, we can see that the Cu, the Cooper, the number is the 29. So you have to know about the shells for each shell, the fourth shell, second shell, third shell, and fourth shell. So each shell has the maximum capacity to get the electrons. The fourth shell, 2, second shell, 8, third shell, 18, and fourth shell, the 32. So in here, the 29, the Cooper means we can, the tracking to how can they consist of the electrons in the shell, 2 plus 8 plus 18 plus, that is what? The 28. And the fourth shell is 1. 1 electrons in the valence shell in the Cooper. So we can draw like this one for the Cooper. Okay. So, now we're gonna learn about is like the charge. So in the previous two slides, we're gonna learn about the how can the atom consist of the components, and then how can we calculate it? What is the valence shell? And then each shell has the maximum capacity to determine the conductivity. So now we have a lot of things like the charge. The charge is, the charge of electron and protons are equal and opposite. So the net charge on the atom is 0. So if an atom lose 1 valence electrons, the atom then contains the fewer electrons than protons. And the net charge on the atom is the positive. Okay, the positive. So if an atom with an incomplete valence shell gains 1 valence electrons, the atom contains more electrons than protons, and the net charge on the atom
the p-n junction
is
bias to make the
negative. Okay,
minimization
right?
of the
So it
resistance,
depends on
the
how
junction
many
resistance. So that
electron
is
contains more or less
increase
than the
the junction
protons. We're
current.
gonna call as the
While
atom charge is
if the
positive
p-n junction
and
was
negative. So
reverse bias, the junction resistance
from these
maximized
slides, we're going to
to
learn about conductivity
reduce
of the
or
atom, okay? The
minimize the
conductivity of
junctions,
atom.
the
So it
current
depends
in the
on
reverse bias
conductivity. We can
cases. Okay.
classify three different parts of the material. So one is insulator, the other one semiconductors, and the other one, matters. Okay, matter is more, more conductivity, more, just a more perfect conductor, right? The matter is like when an atom has one valence the electrons, it is nearly the perfect conductor. Okay, why? Because we're going to learn about for the future. But the insulator, when an atom has eight valence electrons, eight valence electron is nearly perfectly the conductor. Okay, all right. So therefore, conductivity decrease with an increase in number of valence electrons. So from these the two statements, we can acknowledge that it's like conductivity decrease with an increase in the number of valence the electrons. Okay, so the conductors is silver, gold, copper, steel, sometimes water. But the insulator, it was really stable to from the least for safety. We're gonna use a lot of time rubber, glass, oil, diamond. Oh, diamond. It's still a dry wood maybe as well. Okay. So now we have, as I said before, it depends on conductivity of maybe atom, insulator, metals, semiconductor. Semiconductor is very important because we're going to learn about more p-n junction or transistor, a lot of electrons. That is very important semiconductor in here. Okay, so semiconductor has the atoms that contains four valence electrons perfectly. We're going to call that semiconductor. In other words, it is neitherly good conductors or nor or good insulator, because the good conductor, one good insulator, eight they want to help the neither conductor, and then good the insulator. So semiconductors is the three most popular used materials. One is the silicon, germanium, and carbon. Especially from this figure 3, we can see that the valence shell mean the outermost, you know what I mean? Okay, so right, I'm gonna show you more the highlight right there. The outermost shell, valence shell is like 4, the silicon, and also germanium is also 4. So usually, early stage, the germanium used for higher electric mobility and the emergency invocation for high efficiency. But now, silicon will be better to use the more performance issue, the quantum computing silicon, a lot of semiconductor cell phones, whatever. But for the future, the hybrid combinations that will be used more next generation. Okay, now, from here, we're gonna more about us like a physical level to learn about the insulator, semiconductor, and metals in terms of conductivity of the atoms. So the solid state physics, the valence band, conduction band concept is very key concept. So the first over, we needed to learn about really basic concept about the valence and conduction bands in the energy of electronics the figure. So the valence band is highest range electron energies where electrons are normally present at absolute zero temperature. So that was cannot, it is the maximum energy value which is not able to move electrons. But the conduction band is the range of electron energy is higher than valence band. Higher than valence band means like electrons can move freely. The after above the valence band means it contributes to electrical conductions. Okay, so the the valence band, conduction bands between of them is like the energy gap, just like gap. The gap is the energy difference between the two bands. That is the size of get determined material could be determined is conductor, semiconductor, the insulator. So it depends on the gap between the two band, conductor, semiconductor, the insulator. The conductor is no band gap, semiconductor, the moderate band gap. It's like the middle, and insulator is really large gap. Large gap means like it's really hard to make a conduction to free electrons moving. Okay, and the Fermi level is the concept, just the concept, which is used to describe the energy level. The probability of the finding electron is like a 50%. It was a really crucial reference point understanding electronic properties of the materials. Okay, so from these slides, we're going to see that a conduction band and valence band is for insulator, it's really the high large the energy gap. So it was really hard moving free the from valence to conduction band because above the conduction band, it was easily electron moving. But the semiconductor is really the band gap is a center level Fermi level between conduction band valence band. That is not insulator, not the matter. But the matters in here, conductors, that was overlap valence and conduction. So that means really easy without any adding energy could move over the conduction band. Okay, so that is really basic concept in the view of physical level over here. Okay, the doping. What is the doping? The doping is the process of adding impurity atom to silicon and germanium. So that could improve more conductivity of the semiconductor. So it means the after adding two impurity atoms means the doping to the silicon germanium that has more increased conductivity. So the term impurity is used to describe the doping elements because the silicon germanium is no longer the pure ones the doping has occur. Okay, since the doped semiconductor is no longer pure, that is called as the extrinsic or the impure semiconductor. Okay, so they have the two type elements of the doping. The one is the trivalent here, and the other one pentavalent here. So the trivalent element is one that has three valence the electrons, while the pentavalent element is one that has five valent the electrons. So the p-n junctions, we can antimaterial, p-type material just combine. They're gonna call that p-n junctions. To understand n-type and p-type materials, we have to know really importance like the two different elements here. So this is why we learn about a long story about the atomic model and cell whatever. So the n-type material is when intrinsic silicon or germanium was doped with the pentavalent element. The resulting material is called as n-type materials. So the p-type element is five valence electrons, more electrons. So in other words, so impurity atoms with five valence electrons produce n-type semiconductors by contributing extra electrons. So excess electrons as majority carriers in the valence band. So that is called as n-type matrix. However, the p-type matrix is reversed. When intrinsic silicon germanium is doped with the trivalent element, the resulting material is called as the p-type matrix. In other words, so impurity atom with three valence electrons, three valence. Okay, so that produces p-type semiconductor by producing Hall or an electron deficiency. So excess Hall in the valence band. So one more time, summarize the p-n junctions is to connect to the p and n-type materials. So do you remember we learned about the conduction of the atom? We're gonna classify insulator, semiconductor, the metals. So that is also it depends on the valence shell has it was the standard of four electrons. The below four electrons, we're gonna call that the pentavalent. No, it's like the trivalent the elements because there's the three valence the electrons. But the standard of the four electrons above is like the pentavalent elements. There's the five valence electrons, means like the excess the electrons. So n-type, p-type, the how many valence electrons means called as two different elements. We're gonna make it the n-type, p-type matrix. Okay. So the one more time from these slides, the p-n junctions is the boundary or interface between two types of semiconductor materials, p-type or n-type. So the p side contains, we learned before in the previous slides, they have the excess of five valence electrons, while the n side contains the excess the electrons in the outer shells of electrical neutral the atoms. And then we have to understand the depletion layer for the p-n junction, the concept. The depletion layer is an insulating region within conductivity. So from the figure 4, we can see that for the each different p-type, n-type, they have really slightly, the junctions of the minus negative of the p-type materials and positive charge of the n-type materials. Not much, but they have the side by side. They have the meeting in the center of the conjunction in the p-n junction. Okay.